Hello, this is Malek Ayman from Group 7, Computer Organization and Architecture, Section 6. I will be explaining the input and output of our project. So, to begin with, here we defined the, the strings that we will need in the program. So, basically, once the program starts, it asks the user to enter a 4-digit hexadecimal. And then during the output, we will need to notify the user that the 2's complement of the hex is, and then whatever the number. And so we use the string and this, and then the is, and then if the user enters an invalid number, we will use the error string. Otherwise, we will use the answer itself. And then once we are done, we ask the user if he wants to try again, and if he replies with yes, the program will restart, otherwise the program will end. And so if we look here, the offset instruction, so we will call the string, and then we will read the user's input and save it in the EDX and ECX registers, and then we copy it to the copy buffer variable, and then we check if like we check the whole 4-digit, we loop through them, and if it is a small letter, then we go to L3. Then we go to L2. Otherwise, if the letter is capital, we'll go to L3. And so in L2, we will just check if the letter is smaller than A and less than F. So basically, if it passes the letter F, then it's invalid. And if it is invalid, we will jump to the invalid label, where it just sets the output as error and restarts. So basically, and then L3 is the same thing but with capital letters. And then the character digit, the L4, is just the same thing but as numbers. So we will check if the numbers are greater than 0 and less than or equal to 9. And so otherwise we'll go to invalid 2. And then the restart here just asks the user if he wants to restart or reuse the program. And if he replies with yes, the program will restart. Otherwise, we will just end it. We'll just jump to last, which just exits. Yeah, that's basically it. That was my part, and thank you.
Assalamu alaikum, I am Sakib Showmik. I will explain the part where our program checks if the input is capital letter, small letter, or a character digit. So in L1 we have test EAX, which is an operation to determine if the letter is capital or a small letter. So if the letter is capital, then it will jump to L3, else the letter is small or it can be a character digit, it will jump to L2. So in L2, the method will decide the letter is small or a character digit. Test AL is a method where it will be decided that the letter is a character digit. So if the letter will character digit, we will proceed with checking that the validity of the character digit. So we need to compare the input with AL. So if the value of the character digit is less than A, so it is invalid, and if the value of the character digit is greater than Z, then jump to invalid, or else it will just our program will just convert char digit to a number value.
Alright, so I'm gonna start with my part here, which is comparing and seeing if the input is a character or not, and also uh, converting that whether the input is a character or a digit to a number value, to a binary value. So I'm gonna start with first type of input. We have a small letter, we have capital letter, we have also a digit. So starting with the first one, we are testing if the character is a letter, and we are comparing it to 61 hexa. So 61 hexadecimal is character A. So if it's lower than A, jump to invalid. If it's greater than 66, which is F, jump to invalid. So that's because we only accept from A to F. If that succeeded, we will subtract 87 decimal, which is can be seen here, 87. We're subtracting from the AL because we get the lowest we are getting is letter A, and letter A is 97, as you can see here. So we're comparing that. We're subtracting 87 from it because we want to convert it to 10 hexadecimal. And next, we're doing this for the capital letter. We're doing the same comparison, but now we're comparing with capital A, and if it's less than capital A or it's greater than F, it's invalid. If it succeeded to pass this, we will subtract 55 decimal, as you can see here, which is 7 from AL, and it will get us the value of the digit. Because if we put A, which is 65, like this, and we subtract 55, we'll get 10, and it will be also 10 hexadecimal, which represents A. Last but not least, we are doing also the same thing for the character, for the digit number, and we're comparing it with 0, 30 hexadecimal, as you can see here. If it's less than 0 or if greater than 9, it's invalid, and we subtract, after that succeeds, we subtract from 48 decimal, as you can see here, because we want to convert it to a number. So if you put here 9 as a value, we will subtract 48 from it. So if you put 9 as a value in here, we will subtract 957 minus 48 will get us 9, and that represents 9 in binary, in character digit number. Yeah, that's all.
So I would explain this step, which is how we reverse every bit and hex digit and we plus 1 at the end. So basically what we are doing here in code, we are checking, after checking if it is a valid char, they all have shared the same idea. We are changing from hex to the ones complement first for each char, because we have 4 chars or 4 chars that represent a hex value. After change it from hex value into a digit value, what we're going to do is this: we are going to transform it into the ones complement. And how we are going to do that? Well, basically we are going to fill the first byte with the maximum value. We are going to set all in terms of binary. We are going to set all of them the 8 bits into ones. Then we are going to subtract from that the value of the hex value. And by doing this, we eventually are going to get the ones complements, and we are gonna do that for the rest of the for the capital letter, and here it is we are doing this for the small letter, and also we are doing here for the char digit, which means from 0 to 9. So let me just show you an example of what I'm talking about. So here we have, for example, let's follow what's in the PDF and the example. For example, A0PC. So the first letter is capital. So we are gonna move to here and we are gonna check. Then, as you can see in the register of the base register, it says F, which is set to 1 in terms of binary, because every 0 here represents 1 byte. So we are going to set all of them into, and since we represent the byte in here, so it's going to be all of them into 1s in terms of binary. Then we are going to subtract the value of AL, which is in this case is A, which is 10. So we are going to subtract 10, and as you can see, it turns out that the ones complement of 10 is 5. So we are going to keep proceeding until the end of the code so that we can see that we have the same results, and it applies the same logic for the rest of the characters. If either they are small or big or capital or char digit from 0 to 9. So now we are at the end, and you can see this is the output, which is 5F44, which is exactly the same output here. And one extra thing that we are doing, so now what we are doing, we are transferring every char into 1's complement, and when we transform it into 2's complement, we add 1 at the end. And here where we add 1 at the end, we add AL, we add 1 to the register of AL, then we update the buffer that we have used in the first data.
Assalamu alaikum warahmatullah. I'm Sakib Lutful Hassan from group 7 of our project group. So I'll be explaining about my part of the code. Let me give a recap of what part of the codes are already explained, that is handling input and output. And then next part of the code, differentiate between capital letters, small letters, and character digits. It was also explained. And then converting from hexa character to number values, it was already explained. And then it was explained how to transform from hexa value to 2's complement. And lastly, I'll be presenting my part, that is converting from number value to hexa character. So first we'll be checking if it is a valid character digit. To check if it is a valid character digit, we will be comparing AL. So we will be comparing AL with 0. So our condition here is JL, that means jump if less. So it will jump to the next character if it is less than 0. So after comparing, if it is less than 0, it will jump to the next character. And we will also compare AL with 9. Here we will compare AL with 9. So our condition here is JG, that says jump if above. So if the value is over 9, above 9 after comparing, so it will jump to the next character. So our total condition is if it is less than 0 or if it is less than 9, it is invalid. And after making sure it is a valid character digit, we will be converting character digit to a number value using this code.